رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum dear students. I hope all of you are doing well. آج کا لیکچر سٹارٹ کرتے ہیں آج کی اچھی باتوں سے. سب سے پہلے جو اچھی بات آپ کے ساتھ شیئر کرنا چاہوں گی سورہ بقرہ کی آیت نمبر 153 جس کا ترجمہ کچھ اس طرح سے ہے: اے ایمان والو صبر اور نماز سے مدد لیا کرو، بے شک اللہ صبر کرنے والوں کے ساتھ ہے. اسی سے ریلیٹڈ آج کے لیے جو آپ لوگوں کے ساتھ میں حدیث شیئر کرنا چاہوں گی. رسول اللہ صلی اللہ علیہ وسلم نے فرمایا ہمارے اور کافروں کے درمیان فرق نماز ہے، جس نے نماز چھوڑ دی اس نے کفر کیا. اور سیکنڈ حدیث ہے مسلمان اور کفر و شرک کے درمیان فرق نماز ہے. تو ڈیئر اسٹوڈینٹس ہمیں کوشش کرنی چاہیے کہ ہم دن میں جو 5 نمازیں ہم پہ فرض کی گئی ہیں ہم ان کو لازمی طور پہ وقت پہ پڑھا کریں. نماز پڑھنے کے جو فائدے ہیں ان میں سے 10 فائدے جو فی الحال آپ کے ساتھ میں شیئر کرنا چاہ رہی ہوں. سب سے پہلا فائدہ اللہ تعالیٰ کی رضا، دل اور چہرے کا نور، جسم کی راحت، رحمت کا ذریعہ، بے حیائی اور برے کاموں سے چھٹکارا، رزق میں کشادگی، قبر میں ساتھی، نامہ اعمال میں وزنی، جنت میں داخلے کا پروانہ اور آگ سے نجات کا سبب. صرف اور صرف ہمیں نماز پڑھنی ہے اور اس ایک نماز کے ذریعے ہم اتنے زیادہ اس سے جو ہے فائدے جو ہے وہ حاصل کر سکتے ہیں. آج کے لیے جو آپ لوگوں کے ساتھ دعا شیئر کرنا چاہوں گی یہ ایک گناہوں سے معافی کی مختصر سی دعا ہے. رب اغفر وارحم وانت خیر الراحمین، اے میرے رب مجھے بخش دے اور رحم فرما اور تو سب سے بڑھ کر رحم کرنے والا ہے. یہ بھی قرآن پاک کی ایک آیت ہے جو کہ ہم اس کو دعا کے طور پہ پڑھ سکتے ہیں. Dear students, today is the lecture number 2 of Unit 2, which is Vectors and Equilibrium. And in today's lecture, first of all, we are going to study about the addition of the vectors. Till now, we have seen what are the scalars, what are the vectors. And now in today's lecture, we will see how to add the vectors. Since the vectors are not similar to the scalars, they have the magnitude as well as the direction. So to add the vectors, we cannot simply use the algebra, but we have to follow the geometry rules and the vector addition rules to add or subtract or either to multiply the vectors. So first of all, the vectors can be added geometrically and also we can add them by the help of the equations which we will learn in the coming sessions. So in today's lecture, we will see how the vectors can be added geometrically. We can add the vectors geometrically by drawing them to a common scale and placing them by head to tail, such that if the vector A is drawn and we have to add vector B to it, then we have to place the tail of the vector B to the head of the vector A. And then we join the tail of the first vector to the head of the last vector to get the resultant of the two vectors or to get the addition of these two vectors A and B. This rule is also known as the head to tail rule of adding the vectors. And by this method, we can join the tail of the first vector with the head of the last vector. It will give another vector which is the sum of these vectors. This is also known as the resultant vector. Now, the steps which we have to follow for the addition of the two vectors, first of all, we have to sketch one vector according to the scale given in a given direction, such as a vector A and the vector B. Then we have to place the tail of the second vector onto the head of the first vector. First of all, we will draw any one vector, and in this case we are drawing vector A first, and then we have to put the tail of the second vector, which is the vector B, onto the head of the first vector, which is a vector A, and this has to be according to the selected scale and the given direction. We cannot change the direction of a vector. And then we have to join the tail of the first vector to the head of the second vector, and then putting an arrow on the line pointing away from the origin will give the direction of the resultant vector. And we always start drawing the first vector from the origin. So the starting point of the vector A will be the origin in this case. And then to determine the resultant, measure the length of the resultant vector R, we have to convert it back to the given scale, and it will give us the magnitude of the resultant vector. And to determine the direction, we will measure the angle of the resultant with the x-axis. Dear students, with the help of the head to tail rule, हम किस तरह से vectors को add कर सकते हैं? Vector addition अगर हमें करनी है just for the two vectors, उसके लिए हमें सबसे पहले given vectors जो है vector A और vector B, इनको according to the scale जो है वो हमने draw करना है. Just like अगर ये force है या कोई भी और quantity है, अगर ये इवन लेंथ भी है और लेंथ भी इसकी इन टर्म्स ऑफ किलोमीटर है, तो हम किलोमीटर जो है वो लाइन ड्रॉ नहीं कर सकते, हमें उसको सुटेबल स्केल में पहले कन्वर्ट करना होगा, जस्ट लाइक इन टर्म्स ऑफ द सेंटीमीटर्स. तो सबसे पहले हमें इन वेक्टर्स को गिवन स्केल के अकॉर्डिंग जो है उनको ड्रॉ करना है, और इनकी ड्राइंग के दौरान हम इन वेक्टर्स की डायरेक्शन को चेंज नहीं करते. वेक्टर की डायरेक्शन चेंज नहीं होगी, जस्ट हम उसके मैग्नीट्यूड को इंक्रीज या डिक्रीज कर सकते हैं अकॉर्डिंग टू द सिलेक्टेड स्केल. उसके बाद हमने क्या करना है, इन दोनों वेक्टर्स को हम किस तरह से ऐड करेंगे, हम इन वेक्टर्स को हेड टू टेल रूल के अकॉर्डिंग ऐड करेंगे. सबसे पहले हमें वेक्टर ए को ड्रॉ करना है फ्रॉम द ओरिजिन. ओरिजिन 0 0 पॉइंट है, उस पॉइंट से हमें जो भी एंगल इस वेक्टर ए का एक्स एक्सिस के साथ बन रहा है, उसी एंगल पे हम इस वेक्टर को ड्रॉ करेंगे, और जितनी हमने इसकी लेंथ सेलेक्ट की हुई है हम उतनी ही लेंथ का वेक्टर ए ड्रॉ करेंगे. उसके बाद हमें इस वेक्टर ए में वेक्टर बी ऐड करना था, तो अब हम वेक्टर ए के हेड के ऊपर वेक्टर बी की टेल को प्लेस करेंगे, और फिर हम इस वेक्टर बी को जो है वो ड्रॉ करेंगे. और उसके बाद रिजल्टेंट हमें कैसे कैलकुलेट करना है, हमें इन वेक्टर्स का सम कैसे कैलकुलेट करना है, उसके लिए हम फर्स्ट वेक्टर जो कि ओरिजिन पॉइंट है उसकी टेल से सेकेंड वेक्टर की हेड तक एक लाइन ड्रॉ करेंगे, और ये लाइन जो होगी इन वेक्टर्स का जो रिजल्टेंट है उसका मैग्नीट्यूड बताएगी, और इसकी डायरेक्शन जो है वो हम ओरिजिन से अवे जो हमारे पास पाथ होगा उस डायरेक्शन में हम इन एरोज को जो है वो ड्रॉ करेंगे, और इसकी जो डायरेक्शन है उसका जो एंगल है वो हम मेजर कर सकते हैं फ्रॉम द पॉजिटिव एक्स एक्सिस. So this is how we can add the two vectors. Now for example, if we consider the two vectors such as P and Q and we want to add them, so the first step is to draw the axis, the coordinate axis, the x-axis and the y-axis, while the x-axis is the horizontal line and the y-axis is the vertical line. And first of all, we have to draw the first vector from the origin and pointing in the same direction as it has its own direction. So if For example, the vector P is pointing along the y-axis and making an angle of 90 degrees from the x-axis. So we will draw the vector P along the vertical line or along the y-axis, and its length will depend on its magnitude. And then if there is the second vector R, which makes an angle of 30 degrees from the y-axis, or we can say that this vector R is making an angle of 60 degrees from the positive x-axis. So we will place the tail of the vector R onto the head of the vector P. Now we will find out the resultant of these two vectors P and Q, and how we will find out the resultant. We will simply draw a line between the tail of the vector P and the head of the vector R. And this line will tell us the magnitude of this resultant, and its direction could be measured from the positive x-axis. And if you measure from the y-axis, then it will 12, and from the x-axis it will be equal to 90 minus 12. And its length could be measured simply by using the scale, and then you can convert this length according to the scale which you have selected earlier. Now the next part of this topic is to find out either the vector addition is commutative or not. The word commutative means the position of the addition does not matter. Just like 1 plus 2 is 3 and 2 plus 1 is also 3. So vector addition is also commutative because while adding the vectors, the position of the vector does not matter. So either if you add B into the vector A, or if you add vector A into the vector B, the resultant of the addition of the two vectors remain the same. So the order in which the vectors are added has no physical significance. So the vector addition is commutative. It obeys the commutative property. Either we add A plus B or B plus A, the resultant remains the same. Even its direction and its magnitude both remain the same. So अगर जब भी हम वेक्टर्स को ऐड करते हैं, सो वेक्टर एडिशंस में आप किस वेक्टर को पहले सिलेक्ट करते हो, आइदर ए या बी, इस चीज से कोई फर्क नहीं पड़ता. एडिशन हमारे पास जो प्रॉपर्टी है वो कम्यूटेटिव प्रॉपर्टी है. चाहे आप वेक्टर ए को बी में ऐड करो या वेक्टर बी को ए में ऐड करो, रिजल्टेंट का मैग्नीट्यूड और डायरेक्शन आपकी चेंज नहीं करेगी. तो द वेक्टर एडिशन इज कम्यूटेटिव. सो ये चीज हमें वेक्टर्स एडिशन को मजीद जो है वो सिंप्लीफाई करती है. हम इजीली हेड टू टेल रूल के अकॉर्डिंग जो है वो वेक्टर्स को जो है वो ऐड कर सकते हैं. So when two or more vectors are added together, they must have the same units and they all must have the same type of quantity. एक चीज जिसका हमें ध्यान रखना होगा while adding the vectors वो ये है कि उनके यूनिट सेम होने चाहिए. ऐसा नहीं है कि हम फोर्स के वेक्टर को लेंथ के वेक्टर में ऐड कर रहे हैं. सो एडिशन जो है वो हमेशा सेम क्वांटिटी की जाती है. तो क्वांटिटी और उनके यूनिट्स का यहाँ पे सेम होना जरूरी है, अदरवाइज हम डिफरेंट क्वांटिटी के वेक्टर्स को ऐड नहीं कर सकते. नाउ if we want to add more than two vectors, yes, we can again use the head to tail rule. The rules of the vector addition can be extended to any number of vectors. Unlimited number of vectors can be added by the vector addition. So there is only not limited to the number 2, but we can add any number of the vectors. So for example, if we consider the three vectors as A, B, and C, so we will add them. First of all, we will draw a vector A, which is directed along the x-axis, and we will start from the origin. Then we will place the tail of the vector b onto the head of the vector a, and this vector b is pointed in the north direction. In this case, there are not xy axis, these are north, south, and east, west. So the vector a is pointed towards east, while the vector b is pointed towards north. And then there is a third vector, which is vector c, and we have to place the tail of this vector onto the head of the vector b, and this vector c is pointed towards the north, while it is making an angle with north of east. So now to find out the sum of these three vectors a, b, and c, we will join the origin, or we will join the tail of the vector a to the head of the vector c, and the direction will be find it out while pointing an arrow which is away from the origin. So the length of this vector will tell us the magnitude, while the direction will be measured from the positive x-axis, which is from the axis of the east towards the north. So this is how we can add 3 or more than 3 or any number of vectors. And now if we consider the addition of the 4 vectors, which are p, q, s, and t. So first of all, we will select any one of the vector, and for example, if we start adding from the vector p, so we will draw the vector p according to the given scale. Then we will place the tail of the vector q onto the head of the vector p, and then the tail of the vector s will be placed onto the head of the vector q, and the tail of the vector t will be placed onto the head of the vector s. And to find out the resultant, we will join the tail of the first vector to the head of the last vector, which is the vector t. So this will give us the resultant of the addition of these 4 vectors, which are p, q, s, and t. So the vector addition will become more simple if we add them by using the head to tail rule. So this is one of the methods by which we can add any number of vectors. Now there is a term that is null vectors. Actually, the null vectors are such vectors which have the 0 magnitude and have some arbitrary direction. Since these are the vectors, so they must have the direction, but null means nothing, 0. So their magnitude will be 0, but they will have some sort of the direction. And we get the null vector by adding the vector to its negative. A minus a will be 0. The 2 vectors which are equal in magnitude but opposite in direction, so when we will add them, we get the 0 magnitude, but it will have some arbitrary direction. Now there is an example 2.1 in your book. Let us solve this. Example 2.1 is a ship leaves port and travels 200 km at 30° north of east, and then it changes its direction and travels 350 km in a direction of 140° north of east to reach the destination. Calculate the straight line distance covered by ship. Now in this case, the ship leaves the port and it travels 200 km at the 30° north of east. So the first step is to select the suitable scale to draw these vectors. So we will consider the scale as, for example, in this case, we are going to consider the 50 km equals to 1 centimeter. You can also select 100 km equal to 1 centimeter. So the choice of the scale is totally up to you. Then if we consider the 50 km equals to 1 centimeter, then it means 200 kilometers will be equal to 4 centimeter. and the angle of this vector is equal to 30° north of east. It means we have to measure 30° from east towards the north, and then the second distance is 350 kilometers, and in terms of the centimeter, according to the scale, this value will be equal to 7 centimeter, and it will make an angle of 140° north of east, or we can say that 140° from the east. So dear students, हमने यहाँ पे जो कन्वर्जन है लेंथ की वो किस तरह से की है. अगर हमारे पास 50 किलोमीटर जो है वो 1 सेंटीमीटर के इक्वल है, तो 200 किलोमीटर में कितने सेंटीमीटर होंगे, ये चीज़ हम कैसे कैलकुलेट करेंगे. हम 200 किलोमीटर को 50 से डिवाइड कर देंगे तो हमारे पास 4 सेंटीमीटर आ जाएंगे. और अगर हमें 350 किलोमीटर को सेंटीमीटर में कन्वर्ट करना है तो हम 350 किलोमीटर को 50 से डिवाइड कर देंगे तो हमारे पास 7 सेंटीमीटर आंसर आ जाएगा. सो अब हमने क्या किया है, हमने इन डिस्टेंसेस को स्मॉल स्केल में सबसे पहले कन्वर्ट किया है ताकि हम इनको इजीली जो है वो ड्रॉ कर सकें. नाउ द सेकंड स्टेप इज टू ड्रॉ द एक्सिस, व्हिच इज द एक्स एक्सिस एंड द वाई एक्सिस. So the second step is to draw the axis, and you must have to draw these axes according to the scale. So we have the two axes, the x-axis and the y-axis, and in this case we will name these axes as north, south, east and west, since the directions are mentioned in terms of the north, south, east and west. So north, south, east and west. Now first of all, the first vector, that is the vector A, is equal to the length of the 4 centimeter, but it is making an angle of 30° from the east. So the first vector will be drawn from the origin while making an angle of 30° from the east, and this length will be equal to 4 सेंटीमीटर. तो सबसे पहले हम लोग 4 सेंटीमीटर की एक लाइन ड्रॉ करेंगे which is making an angle of 30° from the east, and this vector will be named as the vector A. And now we have to join the second vector. The tail of the second vector must be placed onto the head of the first vector. So at the head of the first vector, we will place the tail of the second vector, and the second vector is of the length of 7 centimeter, and it is making an angle of 140° from the east. So we will draw an arbitrary axis, and it is making an angle of 140° from the east, or from the positive x-axis, and its magnitude is equal to 7 centimeter, or in terms of kilometer it will be equal to 350 kilometer. So this vector is vector B. Now to find out the resultant vector, we will join the tail of the first vector to the head of the last vector. And to find out the direction will be pointed away from the origin. So this will be the direction of this vector, and by measuring the length of this vector R, you can be able to measure its magnitude. And if you measure with the help of the scale, this length of this vector R will come out to be 6.8 centimeter approximately. It could vary plus minus 0.1 centimeter. So now the length is not in terms of the centimeter in our question, so we have to convert it back to the into its original unit, which is kilometer. So now again By using this scale, we will convert this length back into the kilometer. And now how we will convert it? Since in 1 centimeter there are 50 kilometers, so in 6.8 centimeter there will be 6.8 multiplied by 50 kilometers. So now we will multiply 50 to 6.8 and it will be equal to 340 kilometers. So this straight line distance covered by the ship will be equal to 340 kilometers. And to find out the direction, its direction will be measured from the east, from the positive x-axis, and it will be equal to 106 degrees. So the theta will be equal to 106 degrees with east. So this is how we can solve these types of questions in which we have to add the vectors by using the head to tail rule. So to subtract the vectors, the vector will be subtracted from another by the means of the addition of the negative of the vector with the first. So the subtraction means just to change the direction of any one of the vector. For example, if we have the two vectors such as A and B, so if we want to add these two vectors, we will just join the head of the first with the tail of the second to add them, and we get the resultant A plus B. Now to subtract these vectors, we will reverse the direction of the vector B if we want to find out A minus B. So if we reverse the direction of this vector B, we will get A minus B, and if we reverse the direction of the vector A, then we will get B minus A. So dear students, वेक्टर्स को सब्ट्रैक्ट करने के लिए हम किसी भी एक वेक्टर की डायरेक्शन को जो है वो नेगेटिव कर देते हैं, उसकी डायरेक्शन को रिवर्स कर देते हैं. सो डायरेक्शन को ऑपोजिट करने से वेक्टर जो है वो नेगेटिव बन जाता है. और बेसिकली जो सब्ट्रैक्शन है वेक्टर्स की वो एडिशन ही होती है, लेकिन उनकी डायरेक्शन को ऑपोजिट करने से उनके साथ नेगेटिव साइन जो है वो यूज किया जाता है, जिसकी वजह से हम वेक्टर्स को जो है वो सब्ट्रैक्ट कर सकते हैं. Now what if we want to multiply a vector by a scalar? So a scalar multiplication by a vector will change its magnitude, and its direction could also be changed if the scalar is a negative number. So for example, if we consider a vector v, so if we multiply this vector b by a number 0, the constant scalar is 0, then we get a null vector. Then the resultant vector will be 0, because if we multiply any number with a 0, it will become 0. And if the value of the vector k is greater than 0, if it is positive, then the resultant vector's magnitude will increase. There will be only change in its magnitude, its direction does not change. But if the value of the k is less than 0, then the scalar multiple will be negative, and multiplying a vector with negative will change its magnitude, and also it will change its direction. Its direction will now become reverse. It will be opposite to its original value. Or we can say that the direction of the vector will be changed by the angle of 180 degrees. So the first case is we are going to consider any vector A. If we multiply it with a scalar number which is positive scalar number, so its magnitude will increase only, not its direction. If we decrease the value, if we divide this vector, then its magnitude will decrease. And if we multiply the vector with the negative number, then its direction will become opposite. So if initially the vector is present in the first quadrant, then it will be converted into the third quadrant. Dear students, your homework for today is the assignment 2.1 from your book. An airplane is moving at 120 meters per second at an angle of 10 degrees with x-axis. through a 30 meters per second crosswind blowing at an angle of 260 degrees with x-axis. Determine the resultant velocity of the airplane. And the second question is, there is an activity given in your book at the page number 42. You have to draw the vectors in different orders to confirm that the magnitude of and the direction of the resultant of the vectors remain the same. This is the end of the today's lecture. Thank you so much. I hope all of you have enjoyed the today's lecture. For any kind of queries, you can write your question in the comment section. See you in the next lecture with a new topic. Till then, take care and Allah Hafiz.